This is one of those quintessential math problems that always get made fun of. You know, the train leaves Chicago at such and such a time, and another train leaves from Alabama, and they meet in the middle or somewhere. This feels very much like one of those questions. We've got Jerry is on a cross-country trip on an airplane. It's 3,000 miles from his home and then 3,000 miles back. And we know the total time. The total time in the air was 11 hours. So there and back together was 11 hours. If the plane was flying at a rate of 550 miles per hour, what was the speed of the jet stream? And I will say these are great problems to really make you dig into how to do this work and how to kind of grunt through the material and to be a little bit creative in how you set it up. But really, who cares what the speed of the jet stream was? There are other ways to figure that out besides what we're about to do. However, still a good question for doing the work. Okay, here is the big formula that we really need to make this work is that distance, hopefully my pen doesn't die here, distance equals rate times time. That's one that we are inherently pretty good at figuring out. If you're going 60 miles an hour and you need to go, if you go for, I don't know, 3 hours, it's going to take you 180. That's all, or it's going to be 180 miles. Whatever the rate is times the time, that's going to be your distance. Okay, so here we go. I've got two different things, well, three, but two different ways we can go. One direction, you're going to be going with the wind. So I'm going to call that with. And one direction, you're going against the wind. I can't spell tonight, apparently. Pretend that says against. So with the wind and against the wind. If you're going with the wind, the distance is going to still be 3,000 miles. Doesn't matter how fast you're going, the distance stays the same. And we know that the rate is 550 miles an hour. That's how fast the plane is going, 550. However, if you're going with the wind, that means that you're traveling the same direction. I can't really do it. Here we go. Same direction as the wind. The wind is pushing you faster. So the rate is actually going to be 550 miles an hour for the plane plus whatever that wind speed is. I'm going to use W for wind. So that's the rate. It's the 550 miles an hour for the airplane plus the wind is pushing you times time. Okay, going against the wind, still 3,000 miles. You're still going 550 miles per hour in the airplane, but now the wind is going against you. So you're going this way, the wind is pushing back against you. So the wind is going to slow you down. So your rate is going to be whatever the speed of the airplane is minus the wind because you're being slowed down times time. Now, the time. The time is not going to be split evenly. Because you're going slower here with the wind, it's going to take you longer to get home because the wind is going faster. When you're going with the wind, it's pushing you faster. It's going to take you less time to get there. So I'm going to write a third equation over here. I'm going to say that the time with the wind, I'll call it time 1, plus the time against the wind, time 2, so I'll call this time 1 and time 2, because they are different. That has to equal 11 hours. All right, so at this point, we have 1, 2, 3 equations, and there's 1, 2, 3 unknowns. If you have 3 things you don't know, you need at least 3 equations so you can solve for them. We're good, we're set up. That's the creative piece here. Or part of the creative piece anyways. That's filling in the distance equals rate times time. That takes some practice. We're going to keep this going though, because somehow we have to put all these together into one equation with only one unknown. Then we can solve for it. And that's what we want to find is the wind. We want to know that rate of the jet stream. So what I'm going to do is I really want to take this information and I want to plop it in here. I want to take all this information, I want to plop it in here, because then I can get rid of these these variables. So I'm going to look at this equation by itself. If I want to get t1 by itself, t sub 1 by itself, this is times. So to undo that, to get rid of that times, I'm going to divide both sides by 550 plus w. That's going to give me 3,000 divided by 550 plus w equals t1. Hopefully you can see that I was able to just divide this to both sides of that equal sign. We'll do the same thing for against the wind. So I'm going to say 3,000 divided by 550 minus w. It's going to equal t2. So I've solved both of these for t1 and t2 by dividing. And the reason that was at all useful, the reason that's productive, is I have an equation here that relates t1 and t2. t1 plus t2 equals 11. So I'm going to substitute into this formula with these new pieces here. So now I'm going to get 3,000 over 550 plus w plus 3,000 over 550 minus w equals not t2, equals 11. There we go. 11. All right, at this point, it's a rational function and a rational expression. You've solved these. This was the last unit of lessons. This was the last test. I guess the test that's due this coming Friday is solving a rational expression. All right, so let's go ahead and start working on that. If we're going to add, we need to have common denominators. So I'm going to do times 550 minus w to this one. And I'm going to do, I'm kind of running out of room here, but I guess times 550 plus w here. So now they're the same, common denominator. What do I do to the denominator? I need to do the numerator. So I'm going to do 550 minus w there. 550 plus w there. Hopefully I'm not going too fast for you. And I want to have a common denominator over here as well. I know this is getting really messy and I apologize. So maybe I'm going to give myself just a little bit more room. This is like a giant equal sign. There we go. So this equals 11. So still equals 11. That hasn't changed. I've just spaced it out a little bit more to give me more room. I want a common denominator, so I'm going to put over whatever this is, 550 plus w, 550 minus w, so I'm getting that common denominator. Same in the numerator. Whew. All right, this is what I would call the grunt work. Once you've made this substitution, you've done the math, the really hard thinking part. This is just grunt work of getting through the numbers. All right, I've got common denominators. So I'm going to ignore the denominator at this point. They're all the same and they're equal. So this plus this is equal to this. Yep. So I'm going to ignore that denominator. I'm going to clean up what I have and just rewrite this, just the numerator. So I'm only rewriting the numerator. There are other ways to show this. You could talk about cross product. There's lots of ways that you can show why this is true. But the dirty way, the way of not really explaining it, is to ignore the denominator. So I'm just ignoring that. It's already equal, so I don't care about it anymore. This is my numerator. All right, so I've just rewritten it. All right, here we go. So I'm going to distribute. I don't think Newton distributes here. I think they factor 3,000 out and work at it that way. I'm going to distribute. So I need a calculator. I think 3,000 times 5,500. If it wasn't late and I wasn't tired, I might try and work that out. But in my head, I'm not going to tonight. That's a big one. Okay, minus 3,000 w. I don't have to do it again here because I've already done that. Multiplication. So I'm distributing. 3000 plus W, so plus 3000 W equals. All right, so I've distributed there. Before I look at this side, the right side, let's continue looking at the left side. Minus 3000 W plus 3000 W. If I combine like terms, I get 0 W. So that actually cleaned up pretty well. And if I combine these together, I'm going to get an even bigger number. There we go. So I've combined my like terms. I've simplified this whole left side over here down to just one number. So that cleaned up nicely. On the right side, one thing I notice is that we've got 550 plus W and 550 minus W. That is the factored form of a difference of perfect squares. So I recognize, I'm going to ignore the 11 for a second. I'm just going to leave it here. I recognize that if you have the same thing twice, one's plus and one's minus, if you distribute, if you FOIL that out, if you distribute that all through and expand it, you're going to end up with 550 squared times 550 So 550 squared minus W squared. And you can do the FOIL. You know, if this isn't something you're familiar with, expand it out. Do 550 times 550 minus W plus W. You can do the expansion. You're going to get this. Oh, all right, we're almost done. We're getting there. We're getting there. I'm going to multiply by 11, so I'm going to distribute the 11 through. So I'm going to do my number here times 11 and get another really big number. Again, outside of math class, there are other ways to work out the speed of the jet stream where you don't have to do all this work. All right, I'm going to subtract to this side. I'm going to solve for W. So I'm going to subtract from this side. And I'm going to get that equals negative 11 W squared. That minus 11, that minus stays with it. I'm going to divide by negative 11 and get 2500. So we could stop and just ask ourselves, some number squared has to equal 2500. I know 5 times 5 is 25. So 50 times 50 would have to be 2500. If I root both sides. Technically, it's plus or minus 50. You could use the calculator and work it out, but just there it is, 50 times 50. The negative doesn't make sense in this case, so you can't have a wind speed of negative 50 miles an hour. So even though technically it should be square root, it should be plus or minus, doesn't affect us here because the application, the negative doesn't make sense. And that would be the wind speed. 50 miles per hour is the speed of that wind. By just looking at that, that's a lot of work. All right, that's it. That's how you do it. I wish I could say there's an easier way. DIRT is your formula. Distance equals rate times time. Use it. Hopefully this beginning part, what I would consider the more complicated part, makes some sense. And then it's just the grunt work of working through the math there, the arithmetic.